My name is Hui Song. I'm a researcher with Syntax Norway. Together with my colleague Nicola, I would like to first thank OW2 for offering us this opportunity to share with you what we are doing in a project called eHealth. eHealth is a research project funded by the European Commission under the OW2 2020 program. The project is about how to support DevOps as a new way for software development for Internet of Things. We found this problem and we have some good ideas that we believe that will improve the way people develop IoT software. We did some experiment, prototyping, tool development, and we're now in the phase of trying to use them in real cases from some use cases. So this is a typical research process. If you switch DevOps to some other topics, for example, COVID-19, then the process is almost the same, from problem to research to innovation or manufacturing. But what makes this problem a little bit special, which also makes us wanting to share it in this conference, is that there is actually a hidden loop. The whole process is strongly supported or powered by open source. We elaborate that in the following slides. So come back to the problem again. Software development for Internet of Things. When we think about software development, most of us will have the image somehow like the one shown on the left, of a smart guy or girl sitting in front of a clean desk with just the monitors, keyboard, and mouse. You do some change to your code. When you're satisfied, you click some button, and then you can go out to grab some coffee, have some chat with a colleague, and when you're back, everything is online. You start to see the monitoring result on how the system is actually running in the cloud. Easy and clean. But when you think about IoT software development, I think many of us will still have the image somehow like the one on the right. You have a desk which is filled with some prototype devices that weld together in a strange way, old-fashioned monitor, just to make sure you can get some output from some old devices. You still do the change on your code, but after that you need to build it and somehow transfer the code into some, in a special way, into some devices. And after that you monitor how it works in an old way, and if it's something wrong, it's not so easy to figure out what is happening. But does it have to be this way? No, I think as IoT developers, we also like DevOps. We also wanted to be able to focus on the frequent and small changes, small improvements to our system. And we want to enjoy automation. We also like to see the feedback from not only the devices on the desk, but also the ones from our real customers. But it's not so easy, since IoT is anyway special. It's different from development for cloud software. So first thing is that it is distributed and is diverse. You have hundreds of thousands of IoT devices deployed far away from each other, and they are somehow different. Even if within the same application you may purchase those devices from different manufacturers, or from the same one, but they are produced maybe 3 months apart, and then they're different. The devices have different way for you to deploy software. some of them are good enough to support Docker containers, but some others even don't have operating system. Other devices are having different context, capabilities, and user preferences, and you have to handle scalability really seriously. And to make it worse, the smart IoT systems also have actuators, which can impact the physical world. Then you can imagine what would happen if the different actuators want to work on the physical world in different ways. So all this lead to challenges that are not handled by the current tools that are provided for cloud-based software development. That was the question or the research problem, how to support the continuous development and operation of trustworthy smart IoT systems. We try to solve this problem by coming up with a set of software development tools which can be used to automate different phases of the DevOps loop. I'd like to go quickly through all these tools by a complete pipeline. So in the middle is the tool Genesis, which is our solution for the infrastructure as code for IoT, which solve the challenge about different devices having different ways to deploy code. So you provide an abstract deploy model together with the code that you compiled it for the different hardware architectures, and then we deploy them into the devices automatically using our engines that are specially developed for different types of devices. The same tools is also used for different phases, like we can give it for risk management. We use it to support the coding. We use it to support coding, and then we use the same model to analyze what are the potential conflicts between actuators, and use this for and provide the automatic actuation conflict manager. And after everything is ready, we give it to the test and the simulation environment. That is what we provide for the devs phase. And for ops, the same model is first used to a tool called Devon Act, which distributes the parallel active deployment plans into a large number of devices according to their different contexts. And after that, for each device, we use the Genesis engine to actually deploy the code into these devices. After the code is running in the system, we use the same model as the central artifact to coordinate all the feedbacks we get from the system through different tools like the access control, the automatic adaptation based on online learning, and root cause analysis for the behavior problems. So all these come back to the same model and pushed back to the dev phase using the same deployment model. That are all the tools. And you can see that all the research is around how to come up with the best software development tools that fit the different phases of IoT development. We don't want to reinvent the wheels. So the best way, we believe, is to improve, adapt, and customize the existing tools so that those tools that people are familiar with and they like working together with, and then we adapt them to be able to use in the best way for the IoT development. So now comes the question of where we can find all these tools. And I think the answer is very clear now, that nowhere than open source community that we can find the best software development tools. So those are just some examples of the open source tools that we use to develop as the basis to develop our tool. For some of the tools, we really go into the source code, make some hacking changes within it. For some of them, we mainly use them as a service. We call the APIs and get the information from them and adapt it, use in our way, so that to make the support for the IoT development. So just take one example. So one of the tools is called the Devon Act. Yeah, we reused our project name. So the tool is about how to distribute some potential or alternative deployment plans into a large number of devices, depending on their contexts. So analyzed the problem, I figure out that the first thing we need is to know what are the devices and what are the context of each of them. This is what we call the fleet monitoring. After that, we assign the deployment plans to all of them based on the context, and then the mapping will be used as input for the infrastructure as code solutions to actually install the software modules into the devices. By dividing the system into these three components, we found that for fleet monitoring, we have good open source frameworks, and one of them is the Azure IoT Hub, which has both online service and also an open source code base. I think 10 years ago, when you come into an open source community and shout out the word Microsoft, you probably get a lot of angry starings, but I think that's changed. So Microsoft is actually contributing to open source. And as for the device deployment, some of the new infrastructure as code solutions like Ansible, and also our own solution, the Genesis, can also work here. So the problem then is more on the fleet assignment, and we can focus on this as our research effort, and we come up with a solution, model-based solution. So we abstract the information into a standard model and use the theory prover to solve this problem in a mathematical way. Pilot use cases. We also want our tools to benefit people outside of the project. So one of the efforts is that some people from the project has decided to start up their own company in January 2019. The company is about providing the software as a service solution for continuous risk management, providing to the DevOps teams. The company started to have some real users from eHealth and construction domain. But that's one of the 10 tools. What about the others? As a project funded by public money, we really want that all people can benefit from the tools and can even join us to maintain these tools and improve them even after the project is over. So you can probably already guess what I want to say in the next slide. Yes, we have our framework open sourced from the very beginning on GitLab. And we have submitted our application to OW2. So this is our story about a research project powered by open source. Thank you very much